You know that feeling when you're like, did I write off something that could have been a massive part of what I should know to understand to be able to help chase my goals and pursue my dreams? That's kind of what I'm feeling right now. Yo folks, in 1967, Xingyang Guo, a behavioral researcher, this is before behavior analysis, what this channel is about, was even a field really identified and together. It was developing. An especially unique Xingyang Guo, he was an epigenetic behaviorist. The idea there is he was looking at how the environment affects how your genes are expressed. There's a lot that goes into that. I can link a book down below for any nerds that want to jump into that. But there was one experience with this book that I've completely come to rethink as a result of a conversation with some people here that I'm going to show you in just a sec. He was talking about the interest that people had at the time of being able to create mathematical models to be able to predict learning, behavior, what people do essentially. And that was, I don't know, best illustrated through an example where he said, imagine that you have a black box. Here's a black box. Which he says, if you were trying to predict all of the potential influences, all the different things, your morphological factors, your chemistry, your biology, your learning history, those sort of things that affect who you are, who you develop to be, regardless of your species, it's gonna be almost impossible. Like, how do you come to quantify all of those sort of things? And he gave an example of a black box, and this black box goes like this. If you were to drill a hole through one side, back out the other, and you blew a bunch of warm air into one and it blew out the other side, I'm paraphrasing here, you could predict with almost perfect mathematical frequency, if you were to put a fly in there, where that fly would come out. Come out the other side of the hole, right? But if you were to take them into the natural environment and try to predict where a fly is gonna go, it seems impossible. And so when I read this, I remember there's a number of different things that I was reading about mathematical prediction of behavior, and I was like, well, we were pretty good at calculus when I was taking that, at predicting certain things, but human behavior, like I kind of side with Guo on this one at the time. I was like, I really don't think you can quantify those things. When you take something, for example, like learning history, right? Or even the epigenetic view of how your learning history and what you contact your environment will change the expression of your genes, you're talking about measuring things that are almost like impossible to even wrap your head around, like how would we get that information? But one thing's really changed, and it's the ability to collect massive amounts of data. So it kind of comes a question of not whether or not these things would work, but a practical issue of whether or not you can collect the data that you need. And I think those things have largely changed. Clearly, since 1967, those things have changed a ton, but they change exponentially. If you look at, was it Turing's Law? How things are doubling roughly every 18 months in technology. You know that feeling when you're like, did I write off something that could have been a massive part of what I should know to understand to be able to help chase my goals and pursue my dreams? That's kind of what I'm feeling right now. The possibilities of us to be able to take the data that our phones take, any wearables, if you wear those sort of things, your cars, when you're driving around, like there's unbelievable amounts of data now. It's more of a question of, are we collecting the right measures to be able to predict the certain behavior that we're interested in? And so I was rethinking this because I was talking with David Cox. David Cox is a amazing, I call him a unicorn of behavior analysis, because he has a degree in behavior analysis, an ethics degree, as well as taught himself and went through a number of different hoops to be able to learn machine learning. It's just a fascinating human coming together with interests of how do we predict human behavior, how do we do it under the right circumstances ethically, and then how do we do it at scale. And while talking with him on this full-length podcast, and the link and share a little bit with you here in just a minute on, it changed I guess my perspective on the utility of mathematical models. If you listen to the podcast, you'll hear the whole story, but for the most part, I was just stuck in this. The individual level was working one-on-one when I was working with people. But if we truly want to save the world, if we want to create behavioral interventions that affect, people globally, when we're talking about something like a pandemic occurring, right? We can't do that on a one-on-one level. We need to work with computers, technology. We need to work in scalable solutions. And that is where I think behavior analysis, working collaboratively, interdisciplinary with other people, could actually solve some of the world's toughest problems. And to the point that I'm figuring out now when I can start to spend some time learning how to code so I can start essentially understanding and reading other areas. If any of this interests you, human behavior and trying to understand how we can affect large-scale behavioral change, I think the podcast will interest you. I'll play a little clip here, and then I will see you in the next one. Enjoy the clip.
Individual level modeling is what it's called.
Yeah.
And what field is that?
If I have, and a lot of, well, I guess in some of the stuff that we're doing in behavioral health. So, if I have individual data on how, like your wearable technology, how much you're running, physical activity, if you keep a little diet log, what you're eating, things like that. Before, sociologists were great because they looked at groups, patterns, and trends. And some of the early big data stuff was cool because they were mining Twitter or Reddit or Pornhub, like that guy, and realizing like at the population level, there's more people that are using Pornhub than say they're using it, right? And that's interesting. What's cool is as we've gotten more advanced in these areas and technology's gotten better and our math has gotten better, people are now saying, I don't have to just look at that population data. I can pick out this user and I can follow them in time and I can cleave that distribution into thirds and I can send a different intervention to each one of those thirds. What we do as behavioral analysts is scale it up. So I think, long story of circling back, I think the focus on single subject design prevented us from getting involved in some of the group population trends, which is really interesting. Yeah. And I think when we get out of the ability to manipulate and control direct contingencies 40 hours a week for somebody, those skills are good to have. But coincidentally, ironically, I don't know. I think we're at a point now where the train hasn't quite left the station yet because people are circling back to single subject modeling, time series data. They call it different things.
I'll also link this book below. It's just super hard to get because it's been out of print forever. So yeah, that's your Daily BA.